Hello and welcome. My name is Jeff Hancock. I'm a senior product manager here at Siemens Embedded. And today we're going to be talking about how software can enable your next RISC-V device. Think of it as kind of tips and tricks when you're thinking about software for your next RISC-V device here. So before we dive in, let's just take a look at some of the challenges as we're looking at RISC-V. So as you know, RISC-V is an open architecture. It's constantly expanding. We like to think it expands for the good, which it does. But with that growing growth that we have, it's also growing its instruction set over here as well. So how do you keep up with a growing instruction set architecture over there? How do you leverage all of the unique modes and features that RISC-V architecture has to provide for you? And it's, finding that right balance between features and performance. And maybe there's even multi-core over here. So I have multiple of the same core, homogeneous, or multiple of heterogeneous cores, or maybe other things like FPGAs and other things over here that are now all on a single SoC or system on a chip device over here. And maybe you have, IoT connectivity requirements you need for your next device. So how do you deal with things like remote management, firmware update, monitoring, maintenance, things along those lines out there? So these are some of the challenges that we're briefly in this short presentation going to cover here. There's many more, but we just kind of picked the highlights here. So as it pertains to this instruction set, right? So as you can see, RISC-V has done a really good job of creating all the different instruction sets. There's a nice committee that formalizes them, but it's constantly growing. As more IP becomes available, that architecture, this ISA is going to continue to grow over there. So how do you stay up to speed with all of that? Well, luckily that's where we can come in with Siemens Embedded, with a tool chain for you that with different tool chains options, I should say, for you. First off, I mean, there's the easy one, a tool chain they can get from us that's always going to be up to speed with the latest and greatest up there. But sometimes maybe there's some customizations that you want to take place. Maybe you're designing your own RISC-V device and you're creating your own instruction sets over here. That tool chain customization capability, you can leave it to our sorcery experts to be able to manage that for you and do that for you. And then finally, there's also just the support, the tool chain support over here. So CVE fixes, bug fixes, security or safety artifacts, long-term support, other services that we can provide with our sorcery team that can help you with the ever-expanding ISA for RISC-V here. Choosing the runtime, that's the next thing. You got your tool chains figured out, or maybe you don't have your tool chains, but you're trying to figure out that runtime environment here for you. There's a lot of different factors that can go in on figuring out which operating environment you need. Do I need some basic scheduler? Maybe that'll work for you. Do I need a deterministic real-time operating system, or maybe a general purpose operating system like Linux will do, right? There's a lot of different factors and a lot of different things that come into play when choosing those. I'm just listing some of them here. There's a whole lot more than just what I have listed here. But diving a little bit deeper, and maybe just kind of, where people usually start with some areas when they're trying to decide what type of operating environment I have, usually comes down to the performance, right? So do I have a real hard time requirement or not? Think of it real simply. If I miss an event, do I care? If not, then a general purpose operating system may be in play. If you need something that's highly deterministic, though, that you guarantee that you're always going to get events and other things like that, then an RTOS, like a Nucleus, can come into play. There's other factors when you're talking about environments here. What resources do I have available? Do I have not a lot of memory? Do I need a small RTOS to fit in here? Or do I get plenty of memory that, I'm not as concerned with the size of the operating system? Same with CPU resources. Do I have a lot or do I have a little? That'll help guide you in which way best fits for you. And then also boot time. Do I need to have some really quick boot up? Do I have a certain requirement that on reset it has to be booted up within a certain amount of time? And so those are some of the other factors that can come into play here. Also, too, if we start to get into, you know, more complex multi-systems, multi-core and multi-OS systems over here, then you start to really need to think about even more of the software architecture. How am I going to leverage these multi-cores out here? Am I going to have an OS that is doing everything in more of an SMP type manner? Do I want to have more of an asynchronous where I have two different types of operating systems running on the same cores? Maybe I have heterogeneous cores out there. So how do I develop a system that has not only multiple OSs, but multiple cores out there as well? And then just because we haven't made it challenging enough, maybe I even have a functional safety capabilities over here. So now I'm introducing the concept of a mixed safety criticality. And so I'm going to be able to figuring out the right technology to be able to support these homogeneous but heterogeneous systems out there, in taking into consideration how do I effectively utilize all of the resources that are available there? How do I share the resources that are available there? And then in some cases, how do I properly separate the different subsystems on there? On that system. All of these are key factors and when you're trying to determine how to figure out what software is best for your system here. And then finally here, securing the edge, right? So as more and more devices are connected, or maybe even not even connected, right? But you know, you need to have the keeping the device safe from the world, so to speak. So the, you know, over here. So how do we, you know, maybe those are things around like secure boot or data encryption. If it is connected up to the cloud, how do I onboard it? How do I transmit data between the device and my cloud configuration over here? So it's other things beyond all the complexities that we talked about earlier, now adding yet another layer over here. Well, the great news is here at Siemens Embedded, we understand that. We've been around for, you know, almost 30 years just doing all of that. And so when it comes to RISC-V, we're no stranger to this. We've had RISC-V offerings now for almost a year and a half. We were one of the first commercial operating systems out there with our Nucleus real-time embedded operating system to support RISC-V out there, and we continue to make enhancements to that offering. You know, for Nucleus, that's a really small footprint, high performance, deterministic operating system that can provide you that nice solution if an RTOS is needed for there. We do provide full source code and a nice development environment to help you along the way. And it is royalty free with the commercially supported offering there as well, backing with technical support. We do have a Yocto-based Linux distribution over here with our Sokol Flex OS that once again provides a nice tooling, support, capabilities with that. And then I already mentioned earlier in the presentation some of the services that we offer with our Sorcery toolchain. But that's not all we do offer. We do have products out in the market around for the multi-core with our hypervisor, and then also our multi-core framework add-on that can help in that heterogeneous type environment if it's multiple operating systems running on multiple different cores, heterogeneous cores out there, be able to provide you an offering there as well. IoT capabilities, so be able to provide a lot of the services that you need on the device side with the connection to the appropriate cloud vendor over there. And it doesn't matter if those cloud vendors are AWS, Azure, MindSphere, what we're still going to be able to provide and use their connection mechanisms to all those, but also provide the capabilities that you need on the target side here to be able to take advantage of all the services that are available there. Finally, you know, around vulnerability monitoring, that's always super important these days, and making sure that everything stays safe, understanding CVE. So here at Siemens Embedded, we do offer security vulnerability monitoring services that give us state-of-the-art access to all of the leading databases out there. And so we can customize a monitoring system here for you. And then finally, just our soup to nuts services. We are the embedded experts over here, so I'll be able to do things like boot time optimization, secure boot, BSPs, on up. We have you handled here. So, now, I'd like to thank you. In conclusion, over 25 years of experience in the embedded market, RISC-V, across a multitude of industries over here, we can definitely provide a solution here for you for your next RISC-V device here. So I'd like to thank you. And if you do have any questions or like to learn more, please stop by our booth in the RISC-V showplace there. Thank you.